Hey viewers, self exist. I'm myself Syed Mohammad Saif and welcome to my channel Guys and Science. And today I am recording with a new format. Comment me below if it's nice. I will switch to the previous format, that is walking around and talking very loud and making lots of hand movements. But I think it's better because I had not to walk, and I can tell you with less energy to consume, and yes, it's simple enough to get to me to know you. So without wasting any time, today's topic is science of trigonometric ratios, and let's get started. First of all, trigonometry. You get introduced to it in your 9th standard, and in the 9th or 10th standard it is so simple: sine, cos, tan, cosec, sec and cot. The students got trouble while remembering these all 6 ratios, and if you understand all 6 ratios and one more word, theta, is damn simple. Adjacent side, opposite side, adjacent angle, opposite angle, and hypotenuse. Nothing more than that. In 10th standard, some more application of that with the finding the height of the tree, building, and many more things. And some more complex application like the speed of the airplane and the speed of the drone or the shadow casted by a cloud into the water and the length of the pole by which we are observing. It's just a simple application, but when you get crossed to the 11th standard, first you hit the class of physics and you get to know sine 2 theta, cos pi by 2, cos pi by 2 plus 2 pi, tan pi by 3, tan pi by 6. First of all, what is pi? Why the pi is in the ratios? Because the ratio is the measure of angle and pi is a number. Then why it's working here? But as you are working on that and you got the formula of conversion of transferring from pi to the degrees and degrees to the pi, and you get to know why it's important, because it's the circumference of a unit circle. That's the circle with a radius 1 unit. It can be any inches, and that's how we measure the ratios, because the ratios are, that's the topic of another video. But let's get into the main concern. And the second thing you got is, what is mean by 2 pi, pi by 2, pi theta by 2, and it does not end. And the third one is inverse. In the NCERT 10th standard, there is a sentence statement with a star on it, that is cos theta whole inverse is not equal to cos inverse theta, but cos square theta is equal to cos theta whole square. Why? And that's how we get confused, because the domain and the range are completely opposite, and the domain which becomes range later is cut short, and the range becomes domain, and it's also limited to a certain value. And yes, it's not on to function, the sine, cos. So therefore how the inverse is possible, and that's another story, my friend. The main concern is the angles. The angle as stated in the 9th and 10th standard are from 0 to 90 degrees. And that's how we observe the mathematics everywhere, because the mathematics, the triangles also ends with a 90-degree triangle, that is right angle triangles, and you can find right angle triangle chapter but not obtuse angle triangle chapters, because the real thing which concern is the sine. As the trigonometric ratios are redefined, instead of a triangle they stated a circle. If you draw a circle, x square plus y square equal to 1 on a coordinate axis or Cartesian system, and plot a point on the circle and join the line or join the point and the origin, which forms a straight line, the inclination of the line from positive x-axis is counted as the angle measured by that, and the distance, the ordinate of the point on the circumference of the circle is defined as sine, and the abscissa of the coordinate on the circumference of the circle is defined as sine theta, cos theta, sorry. Why it is defined? Suppose we form a line and draw a perpendicular from the point to the positive x-axis that join the abscissa perpendicularly to the positive x-axis, and take that point ordinate and join it to the circle's y-axis. What we form? We form a true right angle triangle. One here and one here. Why does it's important? Because it's a right angle triangle, right, as we had formed. And suppose this angle which we have mentioned, the angle between the line and the positive x-axis as theta, then the opposite side, that's the length, or in short the ordinate, the length of the ordinate of that point, that's the opposite side, and hypotenuse, which is the radius of the circle, and equal to 1. Then that adjacent side, opposite side divided by 1 equal to sine theta, and therefore the length, the ordinate of that point is equal to sine theta. Similarly, by taking the distance from the y-axis to the point, which is the abscissa's length, and measuring similarly with that triangle, and these two lengths are equal, therefore adjacent side divided by 1 equal to cos theta, which means the cos theta is equal to the length of abscissa, or the length of the x-axis bisected by that point, or in short way, the length of abscissa is equal to cos theta and length of ordinate is equal to sine theta. And we can also find out that by vector. The resultant vector equal to x square plus y square. So by keeping it aside, the I cap, the vector on our x-axis is equal to the cos theta, and the vector on our y-axis is equal to sine theta. And that's how we get it. We can also find it using the complex number and all that. Vector is really easy one to explain, but that's not our problem. Our problem is the sign. The vectors can also easily understood the sign. The sign of trigonometric ratios is decided by the inclination of that line on the axis. That means if the inclination of that line is on negative x-axis, then the sign of its cos theta is negative. Or the inclination of that line is on negative y-axis instead of positive y-axis, then the sign of its sine is negative. And that's how we define it. Let's take the case 1 where the line is in the first quadrant, that is between 0 to 90. If we draw the perpendiculars to positive axis and negative axis respectively, we find out the signs of abscissa as well as ordinate are positive, and therefore the cos theta as well as the sine theta are positive. Very simple here. And also the length, the inclination of that point, as we take the perpendicular, is only on the positive x-axis as well as the positive y-axis, so no problem at all. The problem arises when we move from first quadrant to the second quadrant. In the second quadrant, as we take the perpendicular from the point to the y-axis and the x-axis, we find out that the perpendicular to the y-axis lies on the positive y-axis, but the perpendicular to the x-axis lies on the negative of x-axis. What does that mean? That means the abscissa is negative and ordinate is positive. That explains the cos of that angle should be negative and the sine of that angle should be positive. We can measure the other way. If we take the smaller angle between them and measure the value, measure the magnitude of that value, and go as take the value of the cos as negative and of sine as positive, we get the sine and cos of the respective obtuse angles formed here. That's how simple it is. That's what maths define itself, and that's how the angles are defined. There is another theoretical method by we can find the values, like the pi by 2, the adjacent angle. You know, sine of pi by 2 plus theta equal to cos theta, and we can take many much examples, and we can prove by that sine of pi by 2 plus theta equal to cos theta, and cos of pi by 2 plus theta equal to minus of sine theta, because the angle jumps to second quadrant if the theta exists from 0 to pi by 2. And that's how we can also prove, but while keeping it simple, I should be able to explain you all how it works, and that's what I did today. Hope you enjoyed this video. Make sure to like, subscribe, share, and please subscribe. More than 50% of the people watching this video are not subscribing, and they will be everywhere. And we have completed just 600 views on this channel in our lifetime, and it's in these 2 months, and I think it's a very short period to complete 600 views, and help me complete 1000 views on this channel. And subscribe and click the bell icon to be notified. Thank you.